Today, we're going to talk about something really cool. It's a story about an AI that isn't just spitting out answers to questions, it's actually making brand new scientific discoveries. It's solving problems that have had the world's smartest people totally stumped for decades. And to really get it, let's start with the puzzle it solved.
Okay, so let me ask you this. Imagine there's a problem, a really fundamental problem in computer science. One that touches everything from forecasting the weather to building the next generation of AI. And for more than half a century, the absolute best minds on the planet have been working on it, and they've made basically zero progress. It's a total brick wall. Where would you even start? So what was this puzzle? It's about finding the most efficient way to multiply two 4x4 matrices. Now, way back in 1969, a mathematician named Strassen found this really clever shortcut that got the job done in 49 steps. And for the next 56 years, crickets, nothing. That number, 49, it just became this unbreakable barrier. It really seemed like that was the best anyone could ever do. Until now, 48. After 56 years of nothing, the barrier was just broken. An algorithm was found that could do it in just 48 multiplications. It's the very first improvement on this problem in over 5 decades. And the mind that found it? Well, it wasn't human. All right, so let's meet the hero of our story. This huge breakthrough came from a brand new system out of Google DeepMind called AlphaEvolve. And it's an AI that's built not just to understand code, but to literally invent it. So what exactly is this thing, AlphaEvolve? Now, it's not just a large language model like you might be thinking of. It's an entire system, a coding agent. It uses a whole team of LLMs inside this evolutionary process. And its entire job is to discover and improve algorithms by writing code, testing it, and then rewriting it over and over and over again. The partnership here is actually beautifully simple. A human researcher comes in and defines the goal. They set up the what. Find me the fastest way to multiply these matrices. And then AlphaEvolve just takes over. It figures out the how, exploring millions, even billions of possibilities to find a solution. It's a search process that a human could never, ever do on their own. Now, I know this might sound a little bit like magic, but it's a very real, very methodical process. So how does it actually evolve these solutions? Well, the secret is right there in the name, evolution. To really get how big a deal AlphaEvolve is, you gotta see what came before it. Its predecessor, FunSearch, was already making cool discoveries, but it was pretty limited. It could only evolve these short, single functions only in Python. AlphaEvolve, it's a whole different league. We're talking about evolving entire programs, hundreds of lines of code in pretty much any programming language, and it can run really complex tests for hours. The scale is just on another level. It all works through this continuous loop. So, first, the AI system proposes a bunch of code changes. Then it applies those changes to make a new version of the program. After that, it tests it to see if it's any better. If it is, great. It gets added to this big database of good ideas. Then the whole cycle repeats, using the very best programs it's found so far as inspiration for the next round. It's basically survival of the fittest, but for computer code. Okay, so breaking a math problem that's been stuck for 56 years, that's seriously impressive, no question. But AlphaEvolve is so much more than some theoretical tool. It's a full-on discovery engine that is already having a real, tangible impact out in the world. And a perfect example of its practical power is what happened when it was used inside Google. They pointed AlphaEvolve at the algorithms that manage their gigantic data centers. By finding a smarter way to schedule jobs on all those machines, it recovered a ton of computing power that was just being wasted. Now, I know what you're probably thinking. 0.7%? That doesn't sound like a lot, but you have to remember, we are talking about Google's global scale here. At that level, 0.7% is absolutely massive. So what does that actually mean in the real world? Well, it's like getting thousands of brand new servers added to your fleet for free. It's more performance, but with no new hardware, no extra power bill, all of it coming from a smarter algorithm that the AI itself discovered. And this is where it gets really fascinating, a bit like a sci-fi feedback loop. AlphaEvolve was used to optimize a key part of the software used for training Google's Gemini models. The same type of AI that powers AlphaEvolve, and the result was a 23% speed up. This means AI is now actively helping to build better, faster AI. And it's not just computer science. AlphaEvolve has been unleashed on over 50 open problems across all these different branches of pure math. And it's not just finding answers we already had. In about 20% of those cases, 1 in 5, it found totally new, provably better solutions than the best ones humans had ever come up with. For instance, it took on this bizarre-sounding thing called the kissing number problem. It basically asks how many spheres can you get to touch a single central sphere without any of them overlapping. In 11 dimensions, the record was 592. AlphaEvolve found a brand new packing arrangement and proved the answer is at least 593. A small step for a number, maybe, but a giant leap for algorithmic discovery. So when you put all of this together, what does it really mean for the future? It really feels like we're watching the emergence of a powerful, completely new kind of partner in the scientific process. But let's be clear, it's not a magic wand that can just solve any problem you throw at it. It's really important to understand where it excels and what its current limits actually are. The most important thing to get is this. Its greatest strength is also its biggest limitation. It needs a scorecard. It thrives on problems where you can automatically and objectively grade a solution. Is this algorithm faster? Yes or no? Does this packing arrangement fit more spheres? Yes or no? It needs that clear metric to guide its evolution. You can't, for example, ask it to judge the beauty of a poem. But that still leaves a vast, vast universe of problems wide open for this kind of exploration. From designing new materials to discovering new physics, the potential is just breathtaking. This isn't about replacing human scientists. It's about empowering them with a collaborator that can search for answers at a speed and scale we could never imagine. So, the real question for all of us is, with a partner like this, what new discoveries will we finally dare to go look for?